CTM students in the house, welcome to lesson 13.3. You can find it on pages 761 to 767. Some new vocabulary here for this lesson. We are going to define these things within the context of examples. I think that will be the best and most efficient way to define those things rather than to write out definitions. And there's some extra examples in your book for this one. Make sure you are using those. So example one, let's get right into an example and do this. I hope you're writing this actual title every time you're writing 13.3 notes, and then write the title of the lesson. It will be helpful when you go back later to study for the test on this chapter, if you know what's where. So construct a frequency distribution. That's what this whole lesson is about, frequency distribution for the following set of data. In this data, it's representing the number of pets per household from a survey of 30 households. Household just being whoever lives inside of a house. So 30 households, maybe it's an immediate family, maybe you have some extended family members, maybe it's a bunch of roommates living together, but households. Let's say this was the data you collected. So we're going to put this into 6 different columns, 5 rows. That'll be 6 times 5. You'll have 30 pieces of data. So that's a piece of data right there. That's one piece of data, a second piece of data, a third piece of data, and so on. These are all the households with 0 pets. So we have 9 of those. Now I'm just putting them in new columns here just so I don't have to write a string that is 30 long. So I'm just trying to organize my data in a more compact way here. So these are all in order. Sometimes they won't be in order, but these ones are going to be right in order for us to start. So that many ones, then you got a 2, 2, it's like 6 2s, 3, 4, 5, 6, 2 3s, 2 4s, a 5, a 6, and then Crazy Cat Lady has 8. She has 8 cats, 8 pets in her household. And I want you to then make a little table like what you see right here. And in this table, we are going to make the frequency distribution. So this column, I want you to call this numbers, or number, singular, of pets, plural. These are something called my observed values. If you want to get fancy with the language, this is observed values. These are the observed values from the survey that I took right here. Over here is the number of families. This number of families is the frequency. So in other words, frequency, how many times does each one of these observed values occur? How many times does 0 occur? So 0, I want you to line these things up. I'm going to use some light yellow lines just to make it easier to see. You've got the blue lines on your paper most likely, so just use that instead of this. But I just want to keep things straight so you know what goes with what here. So I'm just drawing these in for you. We're going from 0 all the way to 8, so I should have 9 different rows then, because 0 is counting as one of those. I'm going to run out of room here. I'm going to have to squeeze these last ones in. It looks like 1, 2, 3, 4, 5, 6, 7, 8. Yup. 9. I'm gonna make this work. How am I gonna make this work though? Let's move that up just a little bit. Move that up just a little bit. And there, that should work. I'll make it work. Alright, so from here, 0. How many did you observe? How many were observed that had 0? There was a frequency. There was a number of families that had 9 of those families. None of those households I guess that's probably the better way to put it. Let's put households here instead of families. Number of households, because it might be just a bunch of roommates living together, something like that. So number of households, 0 observed value, 0 pets. 9 households had 0 pets. 1, 2, 3, 4, 5, 6, 7, 8 households had 1 pet. So here we would put 8. Hopefully you can see that this is pretty simple. I think the start of this chapter is pretty basic, pretty straightforward. Should be pretty simple stuff to do, at least what we're doing right now. Okay, so 2, there's 6. Let's just keep going down. 3, 4, 5, 6, 7. I know there aren't any, but I'm still going to include that here and go up to 8, and we'll see what we put there in a second. So 3, there's 2 families that had 3. There's 2 families that had 4 households. There's 1 household that had 5, 1 with 6. There's 1 with 8. There weren't any for 7, so we simply put a 0 there. And so that's it. That's all you have to do. If it says to create or construct a frequency distribution, you're just taking the data. Make sure it's in order first. We're going to see one. Next one is not going to be in order to start. Excuse me. We're going to put that in order, and then it's a lot easier to make your frequency distribution table from there. Okay, bye, crazy cat lady. Farewell. See ya. And that is a cool dog right there. I like that cat too. Dogs are cooler than cats, though. Sorry if you don't agree with that. Deal with it. Deal with the truth. Dogs are better than cats. The following data shows the overall, and if you're a Californian, you might be more familiar with SAT. We're going to talk about the ACT a little bit, another aptitude test that colleges sometimes look at, especially in other states. So the following data shows the overall ACT scores of 20 students in Mr. Smith's calculus class. Ooh, calculus. So I'm thinking these kids should be scoring pretty well on these tests. Hopefully they have. Let's write down this list of data. So we're going to have, I'm going to just go with 4 columns, and 5 rows. So that would be 4 times 5, that would be 20 pieces of data. So one person got a 27, one person got a 32, 33. These, you'll notice, are not in order. That's on purpose. We'll see what to do in a moment with that. So 19, 26, 25, 23, 35, 30, 31, another 30, 27, 20, 27, 18, 32, 26, 22, and 24. And a perfect score on the ACT is actually a 36, so it looks like nobody got a perfect score in this class, but this 35, you are going to get into, as long as you have a decent GPA, you'll probably get into pretty much any college you want to with a 35. And as you go down the list, it gets harder and harder. 36, though, being a perfect score. So let's say this is what we want to do here. Construct a frequency distribution with first classes of, we're going to say part A, first class is going to be 18 through 19. Part B, the first class, will be 18 through 20. We don't know what that means yet, first class, so just be patient with that. Alright, so let's look at how we would solve this. So, little SOLN action, solution time. How are we going to solve this? Looking at that, it's not really easy to tell what comes first, second, and third, so let's put this data in order. If it's not in order, if it is out of order, put it in order first. So let's write that down first. Organize the data in order to make it easier to categorize. And let's just look up here. We're going to cross them off one at a time as we write them down. That is the way to make sure you don't miss any and try to have to go back and try to figure out, okay, which one did I miss? Just cross them off as you go. It makes it real easy. I'm going to start with, what's the first one there showing up? Definitely that first one showing up is 18. So I'm going to have 18 to begin. I'm still going to keep it in 5 rows, 4 columns. I'm going to keep that consistent with what I had before. So 18, 19, that's right here. Keep looking. Next up, there is a 20, so I'm going to write 20. Is there any more 20s? No. 21, there's a 21. So write that down, 21. Cross them off as you go. 22, we have a 22 right there. Do we have another 22 going once, twice? No, we don't. 23, doesn't look like. Oh, yes, there is. There's a 23 right there. 23. Michael Jordan is crossed off the list. Let's see, 24. Any 24s? Yes, there's one right there. 24. Any others? I'm not seeing any others. Okay, 25. I've got a 25 here. And it looks like that's the only one. 26. I see one. I see two. I see two 26s. So I'm going to cross off two 26s and put two 26s down there. 27. I see 1, 2, 3 27s. 1, 2, 3 27s. I'm going to write 3 27s then. I got to include all of those in my data, my reorganized data table. I've got next up, do I have any 28s? No. Do I have any 29s? No. I have some 30s. So I have 30, 30. I have two 30s. So 30 and 30. What's next? I've got a 31, a single 31. And then I have 32, 32. Two of those. Cross those off. 33 right there. And 35 right there. Okay. So now I have reorganized my data. And to make this easier, I'm just going to copy and paste this. So you don't have to copy this twice. I'm going to copy and paste this though to the next page so that we can use that blank page before. There we go. So we can use that to, come on, there we go. And I don't have to go back and forth between pages. So now I can use this to help me make the distribution tables. So it's the same thing, just keep that same thing there. I'm going to split this up into two parts. We had part A and part B to this. So part A I'll put on the left side. Part B I'll put on the right side. So I'm going to have part A over there, part B over here. And I'm just going to leave this blank for right now. I'll get to that in a moment. Let's just start here with part A. So part A, it said the first class was 19 through 20. The first class was 19 through 20. I meant to change that, sorry. So this, I meant to change this. Let's erase this. That's why we hopefully use pencil when we're doing the notes. I meant to have that as a 19, not an 18. And I meant to rewrite these. Looks like I thought I changed this, but I did not on my notes before. So that should be 19 through 21 here. So this should be 19 through 20. This should be 19 through 21. That's what I meant to write. And that would change this to a 19. I want to make that a 19. I would want to make this a 19. I think that should fix everything that I may have messed up there. Yep, that looks good now. And so let's get started with part A. So we're going to put the score here and the number of students, the frequency over here. So this is the observed data and this is the frequency. I'm not going to write observed data and frequency every time. It's assumed that we know that from example 1. So from here on out, we're just writing what each row, what each column is representing. So the first class is supposed to be 19 through 20. How many students scored 19 through 20? So to make this easier, I'm going to go up here to the table and just taking my normal color here, my pencil, just circling those values. How many do I see in that class, the 19 to 20 class? I see 3. Okay. Now why, you might ask, why am I not writing every single score down? So basically why that is, so generally we want to keep this not too huge and not too small. We want to have it so that there's enough classes to tell a difference. We don't want to put everything in 2 classes unless there's only 2 scores or something like that. But we also don't want to spread it out too much where it's not really easy to tell where the main distribution of the data is. And so the recommended number in our book is actually 5 to 12 classes, to have 5 to 12 classes here. In example 1, we had 9 classes, so that fits in that range. 9 is between 5 and 12 there. And this, we'll end up seeing what this is. So 19 to 20. And then from there, each class size needs to be the same size as the previous one. So this one had 2 possible scores within it. And so we would go up to 21 to 22. That range of scores, how many people fell in that range? So 21 to 22, let's circle those data values. 21 to 22 is right there. How many are in that range? It looks like 2 fall in that category. Keep going with that idea. 23 to 24, 25 to 26, and so on. 27 to 28, 29 to 30, 31 to 32, 33 to 34, and finally 35 to 36. Okay, how many people are in the 23 to 24 range? I see 2 scores there, so circle that up there. Right, 2 there. 25 to 26 range, I've got 3 right there. So there's a value of 3. That's a frequency of 25 to 26. For 27 to 28, there's no 28s, but there's 3 27s. So this would be another 3. 29 to 30, you've got these 2 values. 31 to 32, you have these 3 values. 33 to 34, just 1. And same thing with 35 to 36, just 1. And then I meant to do this back here as well. Let's put this back here. I kind of ran out of space. But underneath where you see this, I want you to insert that in here. I'm just out of space. So underneath there, if you added these all up, you would get 30 as your total. You should always do that to double check. So if I go back to example 1, 9 plus 8, 17, this would be 23, 25, 27, 28, 29, 30. So that checks out. I know I didn't miss any that way. Here, let's see if they add to 20 like they should. This would be 5, 7, 10, 13, 15, 18, 19, and 20. So the total does work out. It does equal 20. We're good to go there. For this other part, I want you to get out your different color just to make it stand out a little better, make it stand out a little easier. And let's do part B in a different color. I'm going to use red for mine. You can use whatever color you've got for yours. Basically, I'm doing the different color because I don't want to rewrite the whole data table again. I just want to write the table once, or the data values once. And then I think color coding things here will make it easier when you go back to this. So that says the first class is supposed to be 19 through 21 in this case. So that includes 19, 20, and 21, 3 values. And so we would want to include 3 values in every successive class after that, 22, 23, and 24. And then 25, 26, and 27. And then 28, 29, and 30. 31, 32, and 33. And finally 34, 35, and 36. So this one, does it still fall within that 5 to 12 recommended range? It looks like it does. So we got 6 values here. Over here we had 1, 2, 3, 4, 5, 6, 7, 8, 9 values right there. Now, how many students fall in the 19 to 21 category? To denote that, let's just put a line after each part. So we have 4 values there. From 22 to 24, we got 1, 2, 3. Let's put another line right there in the different color. So we got 3. 25 through 27, 1, 2, 3, 4, 5, 6 in that range now. So this becomes a 6. 30, 28 to 30. There's no 28, no 29, but there is 30. There's 2 values of 30, so we have 2 there. 31 to 33, that would be cutting off there. We got 4 values there. And then 34 to 36, there's just 1. If you total these up, we'd have 7, 13, 15, 19, 20. So that still works. And then example 3, I'm going to go back to this table, to both these tables, refer back to these, but we're going to define some words within the context of example 2 for example 3. So final example here, find the following using part B from example 2. And so there are some problems in the book that I'll probably have you work through that will be similar to this. And I wanted to say, sorry, total number of observations, not just total observations. Total number of observations, not that that makes too big of a difference there, I guess, but total number of observations. So total number of observations, well, clearly I hope that is clear to you. That's 20. We had total observations of 20. Example 3, part B. How about this? So in the vocab, you should have seen there it said lower and upper class limits, and you might be like, what are those? Let's talk about that right now. Lower and upper class limits. So we'll underline the words we're defining here, upper, lower class limits. Those are what we're defining within the context of an example, figuring out what they are. So lower class limits, upper class limits. This is from part B, we're saying, so we're looking at the colored part here. So from part B, the lower class limits would be the lowest part of each class. Should make sense, I hope. 19, 22, 25, 28, 31, and 34. Those are the limits at the low end of each class. The lower class limits, in other words. So that would be 19, 22, 25, 28, 31, and 34. You may notice that it goes up by 3 every time, and that should make sense because we had 3 total values within each range. The upper class limits were 21, 24, I'm just adding 3 each time, 30, 33, and 36. Part C, the width of each class, the width of each class. So a class width, in other words, width of each class. What is a width? How do you find that? This one is really easy to think about. Sometimes you might have some decimals to deal with. Sometimes it might be like that. So knowing that this is what you do, I think, is important. That you just use any 2 consecutive class limits. We'll say lower class limits. It could be upper class too. So I'll use any 2 consecutive lower class limits. You could do upper class limits as well. I'm just going to say stick with lower class limits and you'll always be good to go. But lower class limits and subtract them. So that's in general what to do. Specifically for this one, I would take 19 and 22. Those are the first 2 lower class limits. That'd be probably the easiest ones to use. Just take 22 minus 19 in this example, and you would have 3. That is the width of the class in part B. Part D, we are saying the midpoints now. The midpoints, also known as AKA class mark. Class mark. You might hear it referred to as that instead of the first class. Now you've found midpoints before, I hope, of things in geometry. I've found midpoints of, or average values of things, doing a little basic statistics, which we'll hit again later in this chapter. But the midpoint, you find halfway in between then, in other words. So what you really need to do, all you need to do is add the first classes, I'm going to say class, I guess to say that. I feel like that's grammatically incorrect, but I'm going to write it like that. Sorry if you are a grammar grammar person, and you can come and correct me later on this if that's not right. So maybe it's just an apostrophe with no S. I can't remember. Somebody get their English teacher to tell me, help me out. Add the first class's lower and upper limits and divide by 2. Finding halfway in between by doing that. Divide by 2. So for this example in particular here, first lower and upper class limits, 19 and 21. We're finding halfway in between 19 and 21. So 19 plus 21, divide that by 2. I know it's a very easy example here. I know you're probably thinking it's 20, Mr. Wagner, it's 20. It's halfway in between 19 and 21. But we're getting used to what to do no matter what these two numbers are, no matter how complex or complicated they look. If they're nasty decimals, we still just add them together, divide by 2 to get halfway in between. All right, I think, can I squeeze this in? No, I'm going to put a new page. So I'll get one more page, and we'll say part E, the modal classes. Fancy sounding term. The modal class or classes. So I'm going to put the ES in parentheses. Modal class, modal classes. What's the mode? Do you remember mode from a previous math class? Mean, median, and mode. Mode was the number that showed up the most, and so it's exactly the same. Think about mode when you think of modal classes. Which class has the highest frequency? Which class shows up the most, in other words. So if we go back to part B here, from example 2, which class gets repeated most often or has the highest frequency? It's right here. It's the 6, which is going with the class from 25 to 27. So for this one, we would say 25 to 27 is the modal class. If there was a tie, if, for instance, if this was both 6 and 6 here and here, you would say that both 19 through 21 and 25 through 27 would be your modal classes. If there was a 3-way tie, you'd say all 3. There's only one here though, so it's just 25 through 27 since it has the highest frequency. And one more part, part F. The class limits of the next class if an additional class were to be added. So the class limits of the next class, if an additional class were to be added, should be pretty easy to think of. Go back to here, you have this gap or this span of 3 different values. So next after this, you'd go to 37, 37, 38, and 39. 37 through 39 would be the next one. And so hopefully that's pretty straightforward, that would be 37 through 39. For the ACT, you can't get a value higher than 36, so it really doesn't make sense in terms of the question at hand, but assume that it was possible, then yes, that would be your next class, the next class of limits. Okay, that'll do it. Any questions, let me know in class. Have a good day.